How you doing, everyone? Greetings and welcome back to the basement. So what I've got running here in front of me is a little Starfield simulation type thing that I've written in assembly language. And I wrote this so that I could integrate it into my new game that I'm writing for the CoCo and the Dragon called Super Shooty Aliens. Now what I have running here is what I thought it was kind of impressive, but I wrote it to run in an NTSC artifacting mode. Now what I'm going to have to do probably is convert it into semi-graphics some way to get it to work on European CoCos and Dragons in colour, you know, with my game running in the foreground. But I was surprised how little code it took to write this damn thing, and also it was an awful lot less complicated than I thought it would be. Now, I'll be honest, this is in no way optimised, and anybody who kind of knows a bit about assembly would probably look at it and laugh and say it's the most amateur damn thing they've ever seen, and I'm sure they would be right. But nonetheless, I thought it would be worth my while explaining how it works and kind of showing it to you. I thought that you may find this thing interesting. So, just to give you a kind of a quick rundown on what it is, this is running on kind of high resolution, 192 pixels by 128 pixel resolution screen in the CoCo. So kind of high resolution mode. C6 is what it's known as, but it is of course using the NTSC artifacting mode. So it's all been set up that way. I'll show you in a moment. But yeah, it's just a very kind of simple writing. Well, what we do first is we get random numbers that are within our screen buffer so that we have addresses where we can put stars. And then what we do with that is we take bytes that will draw star patterns into a byte. And what we do is we OR them with whatever information is already in the byte we're going to draw them to, and then place them in the byte. And that way we don't erase anything we don't want to erase. What we do then is we pretty much kind of erase all that again. We move all the addresses down one space and we write it back in again. And that's kind of running the whole time throughout a program. And this is what we get on screen. But anyway, if that hasn't made a whole lot of sense to you, don't worry about it. We'll have a little look at the code and I'll try and explain it to you as best I can. So what we have is four main kind of sections inside in this code. We've got the main setup section that you'd have in pretty much any program you'd be running, because what we're doing is here we're setting, in this little part here, we're setting where we want our screen buffer to be in memory so that it doesn't run into anything else. We're kind of placing it in an empty space of memory where we're not going to affect anything. What we're doing here is we are setting up our screen mode, and in this case, like I say, I'm using the C6 screen mode, same mode as I used in Bob and the Alien Fireflies. Only I've added in I've enabled 2 extra bytes here when I was setting it up. These 2 bytes here would normally be 0, and they give us, you know, that green background with the red, green and blue colors that we could draw graphics in. However, enabling these 2 bytes here will give us the NTSC artifacting type thing. So we will have a black and white screen on a Dragon 32 or on a European CoCo, but we will have on an NTSC CoCo, on an NTSC TV, that kind of nice blue and red and black background type thing with white as well. So that's what I'm after setting up here. And what we're doing here is what you would do again after you've set up any screen mode. We're clearing all the memory so that we have a nice clear screen without any artifacts or any garbage on screen when the game starts. The only other little extra bit of setup I'm doing is I'm using this RMB, or this reserve memory byte directive, to put 200 bytes to one side so that we can store 116-bit addresses into memory somewhere so that we can access those all the time and use them. And they are the addresses where our stars are going to sit within the screen buffer. So that's why I've put those to one side. I've called the beginning of that 200 bytes star addresses so I can easily access it. And the very end of it is end star addresses so that I know when I've gotten to the end of it. You'll see that a little later on down in the code. But that is our setup for the program. The second part of the program here, we will run only once at the very beginning of the program, because what this will do is it will pick the locations on screen for those 100 addresses. It'll do it randomly. So what we do basically is we load into the user stack here with LDU our star addresses. So we're kind of loading these 200 bytes more or less into the user stack. So they're all there lined up in a row, kind of standing one front to back in a queue type thing. And what we're doing is we are going to, have I gone too far? I have. What we're doing is we are going to use one of the ROM calls for the 16-bit random number generator. We're going to get a random number that corresponds to an address in the screen buffer, and we're going to store it to the first 2 bytes of those 200 that we've set aside. So the way we do that is we jump to BF3B, which is the ROM call to get a 16-bit random number. And what happens is, instantly more or less, the processor comes back with a 16-bit number in its X register and says, look, I've got a random number here, here it is. And we go, okay, that's great. We need it to sit inside of our screen buffer. And our screen buffer starts at A00. So the first thing we do is we do a check to see, is it lower than A00? Because if it is, it's outside the screen buffer and it's no good to us. So we compare X to A00 and then we branch shift lower to get again. Which means that if it's lower than A00, throw the number away and send the processor off again. If, however, it's higher than A00, that's good. We're 50% of the way there. What we do is we do a second comparison to see if it's not higher than 21FF, which is the end of the screen buffer. So we compare X, whatever number it has presented us with, to 21FF, and we branch if it's higher to get again. So effectively, if it's higher, we throw it away and send the processor back to get another number. If, however, it's lower or the same as 21FF, we'll keep it because it's inside the screen buffer. It's in that kind of Goldilocks zone that we want. And what we'll do if that's the case is we will store the number it has in X to U. So what that'll do is it'll store that random number, that's exactly what we want, into the first 2 bytes of star addresses. And it'll move the pointer, the user stack pointer, on 2 bytes so that we're ready to do the same thing again for the next 2 bytes inside the star addresses. And basically what it does, once it's stored a number there and moved on 2 bytes, it'll check to see if U is pointing to N star addresses, which is here, this label that we've put at the very end of those 200 bytes that we reserved. If it's not pointing there, then it'll go back and get the next random number until they're all full. And once they're all full, then you will be pointing at that end star addresses, and that's it. We can move on to the next portion of the code. Now, the wonderful thing about this is it takes a little bit of time to execute this whole section of code where we're getting our 100 random numbers, but it's only ran at the beginning of the program. So pretty much what it means is it won't be running throughout gameplay as such, so it doesn't take up any more processor time. So, and the beauty of it is, it meant I didn't have to kind of create a matrix where I chose addresses and stuff and put them into the code, which would take up a lot of space and whatnot. Laziness on my part is kind of what forced me, directed me towards using a random number generator. So that's why I've done that. Once we have our 100 addresses kind of found and stored away nice and safe, what we want to do is we want to store some stars into those locations. So what we do once again is we load the user stack with our star addresses. And now what we have is all those bytes standing in a line all filled up with 100 addresses somewhere within the screen buffer that are going to contain stars. And now all we have to do is put star data into those. So the way I've done this is we're just going to load each address into the X register, which is what we're doing here. Having loaded the user stack with star addresses, we will load X with the first 2 bytes in U, and we will advance U on 2 places. So We're after loading it with the first address, and then we tell you to move on to be ready for when we want to fetch the next address. That's what's going on. What we do then is you will see that I have an 8-bit binary number here. What I've done is I've loaded 00100000 into the A register. And the reason I've done that, I could really load any kind of binary number I wanted, but the reason I've done that here is that each byte that we're going to be putting information into here on screen can contain 4 pixels. It's more or less the way it works. So 2 bytes designates the color of a pixel or whether a pixel is off. So what I want to do here is, of the 4 pixels available in the byte we're going to be filling with data here, I just want the second pixel to be enabled, and I want it to be a certain color. So I'm going to turn the first pixel off. Damn, I'm after changing it around. Hang on. Here we go. Yeah, there we go. So the first pixel is going to be off. Second pixel is going to be on. And these pixels here are going to be off. Now, it doesn't really mean much. But the thing is, I've done kind of 5 different instances of this for the first 5 addresses. And that way what we'll get is different colored stars in different pixel placements of the bytes that they're put into. So it gives a more kind of a random kind of a orientation on screen, more or less. But that's basically what we're doing. I'm just putting a value into A that'll turn on the second pixel in this 4 pixel set, more or less. What I'm doing then is I am ORing A. So I'm ORing this value with whatever value is found in the screen buffer that X is pointing to. Now, what this basically means is this. We've got a screen that has information in it, most likely like alien ships or missiles or all that kind of stuff. And we're going to write data to display a star on the screen. If this star is going to appear kind of exactly where a missile is, we don't want the star to be written over the missile because that doesn't make sense. So what we do is we do some binary mathematics on the value we're going to put on screen. So this star data here, if you want, we are going to OR it with whatever's already found there. So we take what we want to put on screen with what's already on screen and we OR them. And what that'll pretty much do is it will allow us to put the star on screen without actually erasing anything that's on screen already. That's what that OR operation will do. Don't worry too much about how it works. I still haven't fully got my head around it, but that's what it will do. We OR A with what's already in X. It changes A in such a way that it won't delete anything that's already on screen, but it will place the star there if the space is available. And then we store A to X. That's more or less it. We're storing our first star into our first star address on screen. Only 99 left to do. So what it'll do is it'll do this 4 more times with different color and different colored stars and different star placements, and then it'll check to see, is you pointing to the end star address? If it's not, it'll jump back up here again and it'll go through it again. Now we have 200 bytes put to one side, which means it contains enough addresses for 100 stars, and we're doing this 5 times each loop, so it's going to loop through it 20 times more or less. And at the end of those 20 times, it'll be at end star address, and then it will go down to the next part of the program here. Next part of the program, what it is something that you wouldn't actually need at all if you were running this in an actual game. And that is a little timing kind of loop where we're waiting just a moment between animations on the Starfield. So what we've done is we've just drawn our stars to the Starfield. We'll look at it for a second or two before we erase it and then move it down a bit. That's more or less what this wait is for. If we were running it with a real game, there'd be enough going on in the real game between drawing other stuff on screen and calculating other ships' positions and doing collision detection and all that, that we would have an ample kind of time wait between when we drew, erased and redrew the Starfield, more or less. So just to demonstrate this program, this part is in here, but it wouldn't be used if we were using it kind of in a game. Now, once we've drawn our stars to the Starfield or to the buffer, and we've waited a moment, next thing to do is erase all those stars, move the addresses down one space and redraw them all. That's pretty much all that's going on. And this here is the very last portion of the program here. And what we're doing is a lot like what we've done in the past. We are loading the user stack with star addresses once again. So we're pointing to the beginning of those 200 bytes that we've reserved that contain the addresses where we want to put stars on screen. What we're doing is we're loading X with the address, with the first address that U has there, and then we are loading A with whatever X has. So we're effectively loading X with the address that U contains, and then we are loading A with whatever data is in that address that was loaded from U. It gets a little complicated that way, but that's what's going on. And then what we're doing is we are exclusive ORing A with X. And as A contains exactly what X had, we are pretty much exclusive ORing A with itself. And again, it's another way that let us erase stars from the buffer without actually touching any information that's on the screen as well, like enemy ships, your ship, missiles, any of that kind of stuff that you don't want touched, that'll break the illusion that the Starfield is actually moving underneath. And once we have exclusive ORed A with whatever's in X, we store A to X, effectively removing the star from the background but leaving everything else intact. Now the next thing we want to do then is we want to change the address so that next time that star is drawn, it won't be drawn in the same place it was, it'll be drawn one line beneath to give the impression we're scrolling. So what we do there is we increase the address by 20 hex. And the reason we do that is that the screen on the CoCo is 32 bytes wide, which means if you want to get from one side of the screen to the next, you need to travel through 32 bytes. Now, if you convert decimal 32 into hexadecimal, it becomes hex 20. And that's why we are adding hex 20 to whatever address is found in X. Because if we start at a location, at a byte location on the CoCo screen, and we move 20 from that byte location, we'll end up directly underneath it. So in order to advance the address directly underneath where it was, we add 20 to it. That's more or less it. So what I'm doing is the address that's in X, add 20 to it. And then what we want to do is we want to compare it to 21FF to make sure that it's not outside the screen buffer, because we don't want it to go off the screen and be lost forever and crash our program. So if it's not bigger than 21FF having added 20 hex to it, then it'll go on, and well, what it will do then is it will store that address back to you. So it becomes the new address that'll be fetched the next time that we want to redraw our stars on screen. That's more or less it. And if, however, it has gone beyond that 21FF threshold, what it'll do is it will branch down to this little routine here, correct location, which is right here. And what correct location does is it removes hex 1820. So what it'll do is it'll take that address and it will remove 1820 hex bytes from it. And the reason it does that is we've been moving all of the addresses down one line. When it goes off the screen, we want to move it right back up to the top again. And as the screen is 32 bytes wide and 192 bytes high, what that means is that there is 6,144 bytes in all in our screen buffer. So we need to move it up that many bytes to get right back up to the top of the screen again. And if you convert 6,144 decimal to hexadecimal, you will get 1,800. So the reason that we're removing 1,820 from the address here is that we already added a 20 here that we probably shouldn't have just before. So what that'll do is it'll bring our address, instead of bringing it down one, it'll bring it right way back up to the top of the screen, and then it'll jump back to corrected, which is here. It'll store the new address back to use, so back into our 200 bytes that we reserved earlier, and move use pointer on 2 spaces so that we can attack the next address in line. And again, it checks to see, are we at the end of those 200 bytes that we reserved, by checking to see if we're at end star addresses. If we are, it will branch to store stars. If we're not, it'll go back and do all this again for the next address. Now, if it branches to store stars, then what it's doing is come back up here to where it will rejoin all those stars again, but of course this time it'll draw them in 1 byte down, and any that went off screen, it'll draw them in up on top again. And that is more or less how this program works. That's pretty much all that's to it. As you can see, this is it running right here. If I could get this thing to stop flashing, stupid thing. Okay, there we go. That's it anyway, running right there. And I can show you that it does actually run fairly well with a game running in the background as well. There's a couple of, like, it doesn't take up a whole lot of processor time to make it work. Oh, hang on, I need to set my joystick type here. Yeah, there we go. So you can see this here is the little game I've been working on so far anyway, and you can see that the ship is moving around fairly okay. Our missiles aren't kind of obliterating any stars. The stars aren't obliterating our missiles. The ship isn't kind of getting in the way of any of the stars either, and the stars aren't erasing any of the ships. So as you can see, it seems to work fairly all right. Now again, the beauty of this program is you can easily add or remove stars. There's nothing much you have to do. The only thing really is that up here on top, if you change this figure, if you wanted 50 stars to be on screen, you would change this to 100. If you only wanted 25 stars on screen, you would change this to 50. So whatever amount of stars you want, you just put double that number reserved kind of as bytes. The only caveat really, and it could easily be sorted up, is that it really needs to be a multiple of 10 more or less, because what we're doing is, as we're running through kind of 5 thingies each time before we check to see that we're at the end, and 5 means we're moving 10 bytes across, really needs to be multiple of 10 bytes, or else we will miss the end star address and we'll probably end up kind of crashing our program if we don't put in a number that's a multiple of 10 in here. But that's pretty much it. And yeah, as I say, it could probably be done an awful lot better and optimized an awful lot better, but I thought you might find that some way interesting. So that's the reason why I've made this little video. So anyway, look, have a lovely Septandy. I'll probably be talking to you between this and then anyway. I'll give you a little update on what I'm doing on this Super Shooty Aliens thing. And if there's any other little bits and pieces I come across, I'll share them with you as well. So yeah, have a lovely weekend everyone. Talk to you all soon. Bye bye.